Alright, so on the review from Friday, alright, so on questions 1 through 3, we're using the following diagram to identify what property, postulate, theorem that justifies a statement. You could also have a definition. So again, things that you can use to justify as reasons: properties, postulates, proven theorems, definitions, and given. All right, those are the 5 things. So now you can't use given when it's saying justify here. So it's only one of the 4. So on number 1, we have angle TYU plus angle UYZ equals angle TYZ. So this angle plus this angle equals this full straight angle. We're adding 2 angles together, so this would be what? Angle addition. So angle addition postulate. On number 2, we have angle XYT equals WYZ. What are these 2 angles? Vertical. So are we saying that these measures are equal because they're vertical angles? Alright. Well, what would tell us that? Vertical angle theorem. So we don't know that they're going to be the same measure because that they are just vertical angles. We know because of vertical angle theorem. So vertical angle theorem. Alright, number 3. If y is the midpoint of xw, so this line here, then these 2 would be congruent. What tells us that? Definition of a midpoint. If we know we have a midpoint, then we know it's bisecting 2 pieces into congruent segments. So this would be definition of midpoint. Alright, going on to number 4. Complete the following proof on the back to prove same side interior angle theorem. So we're going to so now on number 4, I'm just going to do my own sticky note here. We have 2-column proof, statements, and reasons. Now, guys, statements and reasons. So we have first the given. We should go ahead and list that first. So we're given B is parallel to C. How do we know that? It's given. Now, we're trying to prove the same side interior angle theorem. So can we use same side interior angle theorem as a reason? No, not if that's what we're trying to prove. So we need to start somewhere else. Now we've gone over all the other theorems at this point, so we could use one of the theorems. I'm just going to go ahead and start with the postulate. So the one that was the postulate was corresponding angle postulate. So since we know that, let's say 2 and 6, I'm going to go ahead and use one of the angles that we're already dealing with in the final statement, just so I can make this proof shorter. All right. If I had chose 2 other ones, again, it would still work out, but it might be a little bit longer. So I'm going to use 2 and 6. Those are corresponding angles. So I know angle 2 is congruent to angle 6 because of corresponding. I can't write. Corresponding angle postulate. Yes.
So how would you know, like, if it's a postulate or a theorem?
Well, corresponding angle postulate. So out of the couple that we did, the corresponding angles, that was the one that was given to us as a postulate. The other ones were then proven in our book as theorems afterwards.
So then corresponding angles is the only one that's
It's the only one that's going to be the postulate. All the other ones are theorems. Yeah. Okay. So now, on here, So now that we know that these two are congruent, we can also say what their measures what?
Measure of angle 2 equals measure of angle 6.
So we can say their measures are equal. Measure of angle 2 equals measure of angle 6. And that would be, whoops, definition. I almost forgot to write definition. Definition of congruent angles. Again, you could also say definition of congruency. That would also work. So now, again, what we're trying to get to is saying that 2 and 5 are supplementary, right? Yes? So we could say, all right, we need to figure out something with angle 5. So let's go. These two we know are what? Okay, these two are a linear pair. So we could use linear pair postulate to say that these two add up to what? 180. So these two, measure of angle 5 equals measure of angle 6. And that could be linear pair postulate. Oh, whoops, sorry. I said that wrong, didn't I? It's not equals. It's not equals. My bad. What should these two angles do? Add up to 180. Sorry about that. Plus, it was 180. Sorry, linear pair postulate says two angles that form a linear pair must add up to 180. There we go. Because again, it's forming a straight angle. So now, we had, in this last part, angle 2 was equal to angle 5, right? These measures are equal. Or sorry, angle 2 is equal to angle 6. We can go ahead and replace 2 with 6 there. So that's going to plug in right there for that 6. So we still have measure angle 5. But now instead of measure angle 6, we're going to say measure angle 2 equals 180. And what do we do in order to plug that in? Substitution. When we plug something in, that is substitution. All right. Now, what were we trying to get to say again?
Angle 2 and angle 5 are supplementary.
Can we say that at this point now? Yeah, because what supplementary means is that two angles must add up to 180. And that's what we just had in this last statement, that 2 and 5 are adding up to 180. So we can now say angle 2 and angle 5 are supplementary. Why?
Definition of supplementary.
Definition of supplementary. Yep. Definition of supplementary angles. And that's our whole proof for that one. Not just a little bit. So again. And there I had 1, 2, 3, 4, 5, 6. 6 different lines. Could have been longer. Yes. Could have been shorter. Maybe. Again, it just depends on what properties you use. One of the things that I did not do here, but we could have, right? If we went back and talked about congruent, this was a idea that we had earlier. Congruent supplements theorem. You guys remember that one? So another way that you could have went with this was to show, all right, these two. So 5 and 6, right, are going to be supplementary, and then we could have somehow used 2 and 5 because those two are the two that we're going to, and we could have worked our way in there to say congruent supplements theorem. Again, it would have been a little more challenging, but there's another way that you could have went about this. But again, there's going to be several different ways you could approach this. Could you have also used alternate interior angles? Yes. Could you have used alternate exterior angles? Yeah. Yes. Could you have used same side interior angles? No. Again, that's the one we can't use because that's what we were proving. That's the only one, though, that we couldn't use for this. You could use any of the other theorems that we already talked about. So there's a lot of different options as far as theorems that we could have used. We could have even chose to use same side exterior angles. I've been fine with that. But again, this was the only one we couldn't use since that's what we were trying to prove. All right, moving on. But again, I'm just trying to show that there are lots of different ways that you could have went about proving that statement. All right, let's zoom back in here. Number 5, the slope of the line is negative 4/5. What's the slope of a line that's parallel to it? So it's the same. The slope of the line is negative 5. What is the slope of the perpendicular line? 1/5. Again, for that one, opposite reciprocal, so you got to change the sign and flip it. Number 13, are these parallel, perpendicular, or neither? How do you figure that out? Huh? Well, we're going to find, again, to identify parallel, perpendicular, or neither, we're going to have to find the slope. And then if you have the same slope, they'd be parallel. If they are opposite reciprocals, they'd be perpendicular. And then if they're neither of those things, neither. Right? So, we're using A, B, and CD. So I'm just going to write them out real quick here. We have 8 minus 4 over 4 minus negative 2. That's for AB. So that's going to be 4 over 6, which reduces to 2/3. Then we have CD, so we're going to use these 2 points. So 12 minus negative 6 over negative 5 minus 3. Negative 6 becomes plus 6, right? So we have 18 over negative 8. Now that also reduces. That will reduce to negative 9/4. Are those the same? No. Are they opposite reciprocals? No. So it's neither. Again, if it's not the same, then it's not parallel. If it's not opposite reciprocal, it's not perpendicular. So this was neither. All right. Down here. This one's just like what we did on our quiz, right? So these 2 lines, they're saying are parallel. So now we need to say how they're related and what type of angles they are. So, first, 2 and 7. What are those? Alternate exterior angles. And if you want to abbreviate, I'm fine with that. Alternate exterior angles. And what type of relationship would they have if these are parallel lines? They are congruent. All right. Number 7. 4 and 6. 4 and 6 are same side interior. And what's their relationship? They're supplementary, yeah. I don't know why I just didn't abbreviate that, but. Alright, on 3 and 6. 3 and 6 are alternate interior angles. And their relationship? Congruent, good. 3 and 2. Vertical angles. And they are congruent. Alright, 3 and 4. Linear pair. And they are supplementary.
So what are the consecutive?
Consecutive is the same thing as same side interior. So on number 7, if you put same side interior or consecutive interior, that would be correct as well. Alright. Again, I can't remember if I used the word consecutive at all on the test, but again, consecutive will come up more when we get into like our quadrilaterals and stuff.
On the test, when we're labeling the angle pairs, do we have to write, can we just put vertical angles, or do we have to write the little sign too?
I'm going to ask you both, and it's going to be a multiple choice.
Okay.
Yeah. Okay, number 12. What is the slope of the line that is graphed? So, how many units did you go up? How many units did you go over? we go up 2 over 8. So we can say the slope is 2 over 8, or we can reduce that. Again, we should always write it in simplest form, just like it says here. So 1/4. Now, is that the only way you could have done that problem? No. Again, you could have also used your equation, right? So if you did the equation, this point was at 4, 1. So we've had 1 and 4. This point was at -4, -1. So minus -1 minus -4. So here we would have had that again is 2 over 8, which also reduces to 1/4. Again, you can either look at the graph or use your formula. On number 14, find the possible coordinates for D that lies on a line that goes through point -3, 2. So let me go ahead and draw that point, -3, -2. So this is point D. No, that's not point D. It doesn't say what that point is, does it? Oh yeah, B. All right, so there is B. And it's parallel to a line that contains these 2 points. So let me go ahead and label those 2 points. I have point 0, 0 and point -4, -2. So that's my line, right? My slope for that line is going up 2 and over 1, 2, 3, 4. Right? So my slope is 2 over 4 or 1/2. So in order to find another point for this new line, I'd have to use that same slope. So go up 1 and over 2 or down 1 and back 2. So either down 1 back 2 would be a point here, or up 1 over 2. You have a point there, there. Again, we can use the slope as many times as we want. Any of those would be acceptable. So you could have the point -1, -1. We have this point at -5, -3. It only asks for 1, so you don't need all of these. We could have also had the point at 1, 0. We could have also had the point at 3, 1. Or the point at 5, 2. Any of those are acceptable. Right. So if it's not one of those points that you have, it's wrong. But there are lots of options there. On this, are these 2 parallel? Why? Alright, so in order for this to be, well, those 2 aren't a linear pair, but if you use the corresponding angles, this should also be 94, and then these 2 would have to be a linear pair, and they are, therefore, it's supplementary. So, why? So you can say simply yes, and I'm fine with you saying that they're supplementary, and that being the reason. All right. On 16, you have to set up an algebraic problem here. So we know this one's 120. The one that B's in should also be 120. So we're saying that one equal to 120. This one, however, should be supplementary with those 2, right? So that should be 60. So we're going to set that one equal to 60. So we solve for A, subtract 15, and A would be, for B, we'd have to first move the 10 over by adding it. So that gives us 130. Divide by 2 and you get, what was it? 65. Alright. On the last one, we know these 2 angles have to be congruent. We know these 2 have to be supplementary. What are we going to start with? C. Because we have to take the 2 that we know the same variable for and set up an equation with those first. So 4c plus 10 plus 5c plus 8 equals 180. So that gives us 9c plus 18 equals 180. subtract 18, and you have 162. Divide by 9, and you get 18, right? And then, now that we know what this is, we can plug it in and figure out this angle measure. So, 4 times 18 is what? 72. And 72 plus 10 is? So this angle is 82, which makes this angle also 82. So now we know what to set that one equal to. So 3D plus 10 equals 82. Subtract 10, and you get 72. And then 72 divided by 3 is 24. All right. So that was that whole review. All right.